Hello, my name's Bob Buxton of Anritsu. I'm the marketing manager for general purpose bench products. I'm here at IMS2012 and I'm very happy to spend a few minutes talking with you about our new broadband technology demonstration. Anritsu has long been at the forefront of pushing forward the frequency limits for vector network analysis. First to 40 gigahertz, first to 65 gigahertz, leadership in the 110 gigahertz area, and today I'm going to show you the next step. But first, prior to that, let me just talk about on-wafer characterization in general. What you see here is a demonstration of on-wafer probing. Last year, we introduced the world's first very compact on-wafer probe test heads that allow direct connect with the probes themselves. These operate from 40 kilohertz to 125 gigahertz, and they were first in being so miniaturized, but also having leading stability, requiring only calibration to be done once a day, and improving dynamic range by 20 dBs in the area of 110 gigahertz. That has been very well accepted, but we've understood from our customers the need to go to even higher frequencies. So what we've done today is we put together a technology demonstration of a system that goes to 145 gigahertz. We've done this by extending the capability of our modules that we had previously, but also in order to enable broadband measurements, obviously can't work in waveguide, you have to work in a coaxial connector. Well, none existed that could take you above 110 gigahertz. So Anritsu had to do a new first. They had to invent the 0.8 millimeter coaxial connector. Not only that, in order to make sure that this worked within an ecosystem for test and measurement, we had to develop the calibration tools needed. So a calibration kit for 0.8 millimeter, consisting of all the necessary devices to calibrate, even including such fine devices as airlines. So again, Anritsu the first. We will be productizing this product later on, but we really wanted to give people advance notice of where the technology is leading. Thank you very much. So we've just looked at our technology demonstration of 140 gigahertz based on our earlier 110 gigahertz test heads for on-wafer test. We needed to go beyond that though. Just doing two-port measurements isn't enough. In many applications, people need to measure devices with 4 ports, whether this be for signal integrity measurements on differential pairs or devices like differential amplifiers, either characterized or on wafer. So what we see here is, for the first time, Anritsu's announcement of a 4-port version of our frequency extension modules to 110 gigahertz, connected up to our standard VectorStar analyzer and test sets. These modules, like the ones that I showed you earlier, use Anritsu's unique nonlinear transmission line technology, which is fabricated in our own gallium arsenide fab. In addition to that greater dynamic range, using nonlinear transmission line technology also allows the greater integration, getting modules down from a size like this to this very small compact module, which when used on wafer is obviously needed, or even on the bench, allows for much easier arrangement of test devices. 4-port though isn't just used on the bench, it is used in on-wafer measurements, and here's an assembly showing how our modules mount together on a positioner for use with a probe station. And these are 2 modules connected to a differential probe. So again, providing much easier connection, mounting, and use of probe stations for people doing on-wafer differential measurements. Lastly, the use of 4-port devices is also important to signal integrity. So as part of this demonstration that we have here, we're looking at the predicted I pattern on the screen here, based on the S parameter measurements made on these 2 lines. Thank you very much. So here at IMS 2012, I'm very pleased to announce the introduction of a noise figure measurement system from Anritsu, again based on our VectorStar network analyzer, but as an industry first making noise figure measurements using a vector network analyzer to 125 gigahertz. We've achieved this by taking the modules that you've already seen, which are our modules that we use for broadband measurements to 110 gigahertz, and turning them into receive-only modules. By doing this, we get much lower noise figure from the module itself, and hence we're able to measure device noise figures down to 0.8 of a dB or less. Again, this is all the way up to 125 gigahertz, an industry first. Thank you very much. Okay, yet another introduction for Anritsu at IMS 2012. So far we've talked about broadband solutions, making measurements from 40 kilohertz up to 125 gigahertz, or even 140 gigahertz plus. But some people are working in specific waveguide bands like E-band for, say, cellular backhaul, or W-band for 94mm imaging. So we've produced solutions from them in waveguide banded modules that again work together with our VectorStar network analyzer here, and so they can do their waveguide banded measurements, but also if they need higher power, they can also use amplifiers with the through line in the device to create the higher power needed. Thank you very much. So far, what we've seen have been our introductions up to 110 or 140 gigahertz, but there are many people working also up in the terahertz region. So we have a solution for that as well that we're announcing here at IMS 2012, which is a 4-port banded solution in partnership with Virginia Diode Inc. using their modules here. These are 500 gigahertz modules. Here we're doing S parameters on a 4-port device. Happens to be a 4-port hybrid coupler. One of the unique things that we offer when we use our VectorStar system, due to its architecture with these millimeter wave and terahertz wave region modules, is the fact that we can control the power with real-time active power control, doesn't rely on any lookup tables, and this allows us to create very, very accurate power levels and also sweep power over broad dynamic ranges, really satisfying the needs of people who are making measurements on active devices. We can offer this system together with modules up to 750 gigahertz today, and we'll be validating within the next few weeks solutions to 1 terahertz. So thank you very much for looking at this and all the other displays that I've shown you today. We'd very much like to see you come on our booth, and we'd love to have a conversation with you about your applications here at IMS 2012 on booth 807. Thank you very much.